Hello guys, so this is kind of the second video of my current playlist of this chain street competition. Uh, as you can see, 19 days are left for the competition. So yeah, I'm planning to try out some more EDA to think about the features and a couple of more strategy how we can perform feature engineering. So as per my last video, I was thinking of building a transformer and checking how the model will perform. Okay. So I will do a detailed video on that, but I've tried training a transformer, but it was not doing that well. Okay, as you can see, uh, yeah, I was trying to take the date and the time values as um, so basically how the transformer works. So for example, you have a word, right? Phew, what happened? Yeah, I don't know. My internet is pretty slow. But yeah, I tried training a transformer, so I didn't get much uh, like uh, much good result in that. Maybe I was lacking in my feature engineering. But yeah, the my idea was to use a transfer model that can positionally encode the date ID and the time ID, and yeah, it will take all the features, and I was hoping I will get some good result with that, but I didn't get any good result with that. As you can see, like when I was training my transformer, my R2 score was pretty bad, so it was not converging. So, and yeah, I will do a more detailed video once I fix all my steps here. But I guess I'm doing something wrong here. I'm not able to figure it out because my model was not at all fitting over the label. So yeah, I was thinking of doing some more EDA to fix it. But yeah, I will mostly create a more detailed video on this transformer training once I fix all the details. So yeah, okay, coming back to, so yeah, I did some correlation plot, and as per my observation, I didn't find any correlation for feature 6, like this responder 6, which is our label. Yeah, you can see like here none of the features are correlating with responder 6, so god knows like what will I do. Yeah. uh yeah, so I basically did this correlation plot per partition of the data, but I am not seeing any correlation with any of the features. So everywhere this responder 6, so yeah, how I'm doing is like I was plotting all the correlation values, but I was plotting them with a mask of 0.3. So whichever values are more than 0.3, they should be displayed, but otherwise uh, they will not be. Yeah. As you can see, none of the correlation are at least like 0.3. So I am not sure if any feature uh, like aligns with responder 6 uh, that can give me some signal. Yeah, you can see, yeah, everywhere here. None of them are related. Everywhere responder 6 is white. Yeah. So I was thinking of doing some couple of more PDA on the dataset. Yeah, so last time I only ventured this one, this train parket, and this thing, this lags, parquet, feature, responder, these things are yet to be explored. But yeah, so, so let's explore them. So yeah, I've just created a basic config of the features and the location of the parquet files in this notebook. Let's start this. Yep, please. And like I'm feeling that Kaggle is not doing that great in the UI. Like I'm keep getting this notebook restarts, and a couple of time my cursor is going somewhere else. So I'm not sure is it my issue or it's a UI issue. So yeah. So feature CSV metadata metadata pertaining the anonymized features. Okay. Responders or CSV metadata pertaining to the anonymized responder. Okay. What is the meaning of pertaining? Be appropriate related to. Ah, okay. Metadata related to anonymized features. Okay. Interesting. Okay. Let's check check them out. Exploring dataset. Okay. First thing first, let's move out this features df pv dot read var. Yeah, you can see like I'm typing something else, it's giving me suggestion of something else. I don't know. Not very not very good at UX wise, like user experience wise. So yet to say, but yeah, and yeah, it's a CSV, right? So okay, this is not a CSV and CSV. Okay, I need to run this. I already run this, right? Yeah. Okay. At the discussion. Tags are used to group features and responders so that even though they are anonymized, we can have an idea of which share similar characteristics. For example, tag 10 might be something like features which are derived from volume data. Okay. The tags are different between features and responders, at least based on my understanding and reverse engineering of the tags. Are the tags in the responder? Oh, there was a responders also, right? Responders df period csv config. What was the name? What about these tags? Okay. Yeah. The Chinese responders, the same or different? Different from what I. Okay. Okay. So it is. Okay, it's taking long time. Ah. So from what I'm understanding is that tags are some kind of variables. Uh, Tag. Okay, and my feature is a function of some variables. Okay, on which these were derived. So that means what? Similar characteristics for your tag might be something like features which are derived from volume data. It's the same. Features clustering and tag analysis results. I came across this 4 cluster with tag 3, 7, 14, 12. Hmm. 3, 7, 14, 12. Hmm. So these are all true, false rule. Let's convert them to integers. So I need all of them, all of the rows, but I need from 1 as right and okay. Mm, I'm saying I need all of them. This will be int We do something like this, right? Is it dialog? Mm-hmm. Ah, okay. Now it looks good. Okay. I see lots of zeros. Mm, okay. So they are saying tags 3, 7. And 14, 12. Hmm. So from what I'm understanding is uh okay. I told with this. So it's basically saying hey, I have a F1 here. I have a F2 here. I have feature 3, feature 4 here. Now this is connected, uh, like these are connected by tag some I, okay, as true, or it can be something like wherever there is true, I guess it means this variable was used in this feature description. uh yeah, with the same analogy I can do here. This is pretty small. So yeah, for me responder 6 is there, right? Now for responder 6 I can see tag 2 was used to derive it. Okay, so so responder 6 is some value for which this tag 2 was used. Okay, okay, and I can see here responder 0. In responder 0 tag 2 was also true, and it was same for 3 also. So it's something like all are connected to like 6, responder 3, responder 0. So all are connected via this tag 2. So it can happen like if I predict this and this, okay, then because from my EDA correlation between responders, yeah, Let's see. Responder 6 now. Yeah, I can see. Okay, it has a very high correlation with this responder 3. Yeah, it has a high correlation. And with responder 0, it has a very low correlation. Okay. Okay, it has very high correlation with, if I see the 40% one, then this thing 8, 7, and 3, no? 8, 7, 3. Doesn't make sense. Is it because, let's take this. So I have true here, and I have here, and in 3 I have here. Okay. So false should also be taken into account for defining relationship. Not sure. Okay, so responder 2 have 3 false, 2 trues. It has how many? 3. Yeah, again 3 false, 2 trues. 2 has 2 trues. Yeah, again, same story. 3 false, 2 trues. 4 also has 0, 1, 2. Yeah, 3. Yeah, it has 2 trues and 3 false. Yeah, 3 false, 2 trues. I have a true like this. This is false, 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 true, true, false, false, true. Okay, 3 false, true, 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 false, false. Okay, not sure whether I'm thinking correctly. Again, 2 trues, 3 false. For 6, there is only 1 true, and 4 of them are false. 7, same story. 8 also same story. Interesting. Not sure how will I use it. But yeah, I'm still thinking, do I need this? Because if I have a correlation plot, I can use them for eliminating like very highly correlated features, right? I can use one of them, or I can use a derive get derived feature out of them. How will I use this information? Not sure. Okay. Then let's see the lags data. I have lags data, right? Yeah. Now this is a pocket. Okay, I see this one. Yeah, and as per the problem, they have said that this lags values of responders 8 lagged by one data ID. The evaluation API serves the entirety of the lagged responders for a data ID. On that data ID is first time ID. Okay, in other words, all of the previous data responders will be served at the first time step of the succeeding date. Okay. Oops. Okay. Yeah, my charger just fell down. Okay, cool. Recording still on. Yep. Okay. So as per them, they are saying like this lag data. So for each responder, they are giving the data ID is first time ID. So yeah, like date ID some, if current date ID is some n, if I'm my current date ID is n, so for each responder they are giving me the responders i's last date IDs, last date IDs, first time ID. Okay, this value, but previous one, which is n minus 1. Okay. Okay, I guess that makes sense. Yeah, basically for if I open this file, let's open it on the top. So part 0 df packet config. Yes, I have saved it in this name. Format part ID equal to 0, part 0 df, and I want to sort values by date ID, time ID, and yeah, how many symbols I have? I have 38. Let's see, let's check out the first 38 symbol. So symbol ID, yeah, I got this. Yeah, I'll go in place. Yeah, and let's check out part 0 df, and let's check out the first 38 rows. Okay, and I'm only interested in responders. So recalls. Okay, I need date ID, time ID, symbol ID, uh, let's put in weight, and let's put them in a list. B or I can say for call in part zero dear dot columns, or yeah, okay, columns if my call out starts with res, and let's check this out. Oh yeah, I don't need this, I don't need this. Yep, yeah, this looks good. So I only want to look at this, not the feature one. So yeah, will it work? Cool. Yeah, okay, 38. So for the state, yeah, okay. So this basically says that for date ID 0, time ID 0, symbol ID is 0. Okay, 0 is not there. But yeah, if I look at this row, okay, so for this, the flag ID is this row, which basically means like for this one, okay, the previous date lag value were these one. So yeah, I need to like some kind of left join them. Okay, okay, this is lag, right? Okay, and they are serving me like this. Yeah, they're serving me the first value, right? Yeah. All of the previous date responders will be served at the first time step of the succeeding date. Yeah, okay. Okay. Now I have this. I just need to know like whether this value is where the like the if it's the price of the stock, it's like the value which is the last value recorded for this symbol ID, or is it some other kind of value? They're serving me like they will be giving me this, okay, and for each symbol ID they are giving me this, right? Yeah, I mean, yeah. Hmm. Okay. Okay, so what I can do is for the creation of my train and validation set, I still don't know like what is this value. So yeah, basically it's something like okay, let's say if we are saying about stock market. Okay, so let's say this, if we are looking at some intraday plot. Okay, so this is kind of the opening price, which will occur say 9:15 a.m. and this is like, let's say this is the closing price, which is happening at 3 p.m. Okay, and this is for D1. Okay, now for the next day, which is somewhere here, let's say 9:15 a.m. again, I will again have some value. Okay, so they are giving me all this per time ID. They are giving me the responders value. Um, I'm assuming like responders are my stock value. Okay, and this is for day 2. Okay, and whenever the inference API is giving me data, it is giving me a lagged value of this stock. Okay, for me, I don't know whether they are giving me the last value of the stock or somewhere the max value of the stock, or is it some kind of like mean value of the stock. Okay, so this I don't know. Okay, so yeah, so they are giving me this. Now what I can do is, so whenever they are giving me this part, okay, so I can basically use this data, that the lagged data that they are giving me, and I can do a left join on this. Yeah, and lag data are a little powerful in time series, because if we are training some classical models, then because classical models do not have that privilege of going back in time, like in neural network what you can achieve, right? So they need some kind of a tabular data. Okay, and in that tabular data, in the column itself, you have to uh, fix it the value. Okay, so if it was a like a neural network kind of model, I could have given, so for example, I have been given like say 15, 20, 11, 12, 20, 43, or 15, 10, 11, 12, 43. Okay, so neural network can use this kind of information, like some kind of a sliding window kind of feature they can use. So for example, next token prediction that we have in uh, neural network. Okay, so this uses some kind of a sliding window. It will take a window of features and it will predict uh, this one. Yeah, but for uh, some classical algorithms, let's say you have Xgbost, or even let's say decision tree, random forest, another popular algorithm, let's say light GBM, and there is this famous Catboost. Okay, so I guess Catboost has it. Okay, because it's also a boosting algorithm, but I guess their package support this sliding window kind of feature. But these algorithms, they need some kind of a tabular information. So if I give you something like this, say 15, 10, 11, 12, 20, 43 as some, let's say some feature. Okay, I have to manually lag them. Something like this will be served here 15, 10, 11, 12, 20, 43, like whatever next value is here. Okay, so this will be like f -1, so it's like lagged by 1 day, and let's say f2, and this is something like lagged by 2 days. So 15 will come here, 10 will come here, 11 will come here, 12 will come here, 20 and then 43. As you can see, like I'm shifting it down, down, down. So this is how we prepare lag data. And for this, I guess they have given that for uh, so that we can leverage this information and bring out some feature engineering. So yeah, okay. So from my transformer training, what I'm observing, like uh, the choice of which partition you are using for training is very essential. And as you can see, like Kaggle is providing us only 30 gigs of RAM, and these datasets are pretty huge. So I mostly have to use at least like at max one or two partition, not more than that. Otherwise, this RAM will exceed. So yeah, okay. Let's prepare our lag dataset. Okay, okay, got this. Now we have to choose a proper partition. Okay, so how I done this analysis? The number of null values. Mhm. Uh, Let me have a look. Okay, this is for one partition, right? Okay, let's do a null count quickly. Okay. Yep. Okay. Uh, Ideally, I can choose the last one because I'm assuming last one will have. So it's something like why like guessing like last one will be better because we are getting historical data, right? Okay. If I if at T naught we have some data, okay, it will, so most likely the data and the capturing amount, it will increase gradually as the time progresses, right? So initially at T naught we have some data, and when I'm at some Tn, like at the end of the year, okay, or at the end of data gathering, usually this pattern is mostly observed. Some nuances can be there because of some errors or some kind of let's say company closing or something happening. This might lead to somewhere like this, okay, but the chance of this happening is pretty rare, okay. But normally as the time progresses, the amount of data we capture also like increases. And earlier I was reading all these data sets. Actually, I should close this. So partition, the last partition was pretty like it was pretty high. Not sure if I have that count. Hmm. Somewhere I have done that. I have to check. Okay. Yeah. As you can see, like partition 0 and all this data were sorted by date ID and time ID, right? So, as you can see, like we had 2 million initially, then in partition one we have around 3 million, then again 3 million, 4 million, 5 million, 5.3 million, 6.2 million, and this like this. So as the time is growing, the data capturing is also increasing. So yeah, I'm just assuming this one will be the we can easily choose the last one for training. But yeah, let's check this. I don't need df sizes. So what I need is, okay, I have to monitor this quickly for path, and the number of files I have is 10 files. So for in range 10. Okay, so I'll be reading them. I'll be doing a null check. Okay, so df use display df. I don't need, let's print this information. Config yeah, part id will be I, and yeah, I will be reading this file, this path. Let's print this path, and I want to see the null values. Yeah, and I have to clear out the memory and see collect. Okay, it doesn't show me all. Okay, is it still there? Okay, it's not. If it's a data frame, I can plot them, right? Big size, let's go with 7, and I need bar plot. Yep, I need bar plot, and my access will be so null counter, and y will be the values. So not sure whether this is what I'm looking, but yeah, and I should use C1. Just make the coloring more good. SNS, and yeah, and from warnings import filter warning. Yeah, filter warning and ignore. Filter warnings. Does it? Okay, cool. And yeah, I got this PLT title. Now title is I can say preview file path reality show. Will it work? Okay. Uh, is it bar plot? I should prediction 90. Let's stop this. As you can see, my RAM is getting exhausted. Yep. Let's check for one first. Yep. Okay. I can, yeah, let it be. I can mark this. Okay. So yeah, here you can see like we have lots of NaN values here. Yeah, this is in like millions, so 2 million NaN values we have here. And yeah, here we also have this partition 0. So as the partition or the date is increasing, yeah, so those of you who are getting confused, like why I'm saying as the partition is increasing, date is increasing, because in this competition they have mentioned that uh, the date ID and the time ID are ordinarily shorted, providing a chronological structure to the data, although the actual time intervals between time ID values may vary. So whatever date ID they have given, so those are like shorted. Yeah, those are shorted already. So that's why I'm saying as I go from partition 0, it will be containing from 0 to 169 days values. I earlier I ran a EDA which was showing like I have a 169 days value in one partition, then in the next partition 172 plus 170 plus 169 values, so that will come out to be 339. Yeah, 172 339 values, 339 days. So yeah, as they are increasing, so yeah, that's why I'm saying as the partition number is increasing, the date IDs are also increasing. So yeah, that was just the analogy. And an observation you can see here, like at partition 0 we have more NaN values on features 0 1 2 3 4, yeah, 0 to 4. But as the partition is increasing or the time is increasing, those are becoming like the null count for them is becoming 0. Partition 9. And yeah, they were in millions, but yeah, I can see 350,000. So we have very less null values in the last parts. Yeah, as you can see, like from millions of null values it was reduced to 400,000 values. So okay. have to create null values, right? For each date ID and symbol ID, I have to create null values, like null value. Sorry, I'm saying lagged values. Uh, yeah, so the proper way of doing it will be, so whatever current DF I have done. Yeah, so DF will be none, I guess. Is anything there? No, right? And yeah, I hate this lazy loading of like lazy uh uh so in Python this memory does not immediately go away. So they have a lazy mechanism which will have references to the variables, and after certain time, if the references are not used, then it will clear uh those references out of the memory. So it has a lazy garbage collection. So yeah, I hate this because I'm done with my thing, and as you can see, like I'm declaring the variable and performing this, but yeah, still it's not clearing out memory. One more thing, just to double check. Yeah, but I actually don't need this because GC collect does that. Let's clear the memory. Okay, so let it run. What I will be doing is I will be creating lagged data. Okay. So partition 4. Okay. And I've added an ED to the ranges of the data IDs. Yeah. One 172, 139. For the last one, 15. Yeah, 1530. Yeah. And this is 13, 160. Okay. So okay. Uh, Now I need to take a sample data and run some models over it. But in order to do that, I need to attach those lagged features. And in order to do that, I have to uh, create those, right? So let's take the last two data frames. Okay. And not sure whether it will be low. So let's take the last one. Okay. And packet config train pretty for format part id, and yeah, and take the last one. Okay. I'm picking the last one because it has lesser null values, and since it's the recent one, so more data is there, so I can use that partition. Considering the last partition for uh, training and data set. I got this. Now I need to create lag data, right? This will be still a little less. I'm just thinking because I will only have 169 records. The last one has having 168. So RAM can be an issue if I concat them. Hmm. But yeah, okay, let's try this. So I need to create lag dataset, right? So it will be same as my copy, but yeah, I don't need copy. So rest calls will be call in call in my data df dot columns if call dot starts with yes. Okay, these are my responder columns. Now I need to add to this responder columns. Now I'm still not sure what are those lag data, so I can consider them to be the mean. Okay, so these are this. So data group by data df group by. So I want to group them by date id, time id, and I need date id, right? Date id and symbol id is Okay, and then my aggregation will be mean, and I need rest calls. Yep. Okay, I got this. Now I need to rename this. So reset index. Yeah. Now the idea will be, so for date ID 1531, okay, I'll be using this data as the lag data for that row. Okay. Yeah, I can paste this here. Okay. Some of this, and yeah, we should do a data group by of data ID row plus one. Yeah, now I will join them, but before I have to rename these columns by lag data. Okay, so the pattern is what's this one? Yeah, so it's responders and lag one. Yep. So responders will be some I. Okay. Now actually I can use something like this. Group by dot columns. I got this. I got this. Group by columns. This one. So wherever I have this, I'll simply write one. Boom! I got a cute little error. What's this? I'll make this. But yeah, okay, this is how my lag data looks. Now what I need is now my current data df. Yes, join is the method. And join. Okay, you take this and on. Then I need left join. Yep. And yeah, let's look at an example. So I am taking other and this is key. Yeah. So wherever I have those data ID and symbol, I will concat them. Yeah. I can use multiple columns, right? Where it is using on. Okay. On, can I pass a list? Does it take a list? On string list. Okay, it takes a list, which is cool. Date ID and symbol ID. And this is join. So data lag df, data lag df. Okay, left one must equal the levels of left in index of right. Okay, len of left on must equal this. Was it a left join? So left join is by default, right? Mm, okay, so wherever there are values, you will attach them. Inner is wherever they have common values. Okay, inner is not the one. It should be left join. Mm, but yeah, I have this many rows. Okay, let's use some kind of data science skills. I can use a lambda. So if I do data group by data ID equal to 1 and data group by, I'm just kind of running a experiment to check if I can run a lambda. Yeah, but okay, so I can use this kind of mechanism. So first what I will do is I'll basically define these columns in my data frame. Okay, so then But I need only for 6, right? Yes, I only need 6. So yeah, this will make my work more easier. So what I will be doing is responders like this. So initially it is with 0 times len of data df. Okay, and data df, um this thing. Okay, and this responder 6 lag 1. Yeah, apply. I will use a lambda, and I will use this thing, access 1. So now I have all of this thing. Okay, now what will I do is, so group by, let's pocket this. So data id, if I do values, it will give me this. If I do 0.0 and this, it gives me error. Okay, yeah, it still gives me error. Okay, it will be long and not a correct way of writing code, but yeah, I can do it, so I will do it. Okay, so symbol id this, and I'll get values of 0. Okay, and this I will do if my this thing len is more than 0, else I'll stick to 0.0. Yep. So yeah, I need you. Now I should have this. Okay, taking some time, and I get error. Oh yeah, so it's data ID. Hopefully it should work. But it's taking time. Maybe I fucked up. It's taking a long time. But yeah, this is the thing. Now I will have all these data points. Now there are still nans. So how should I fill them? But yeah, it depends like how I want to use them. So let's start with a linear regression. If I do a linear regression, then all the values should be, yeah, then all the values should, like, there should be all values. Otherwise, it will give me error. Tree-based algorithms can take care of NaN values, but hmm, this kind of linear algorithms will give me a cute little error. Okay, so filling NaN values. So there are NaN values, right? So let's quickly fill them with 0. So df fill NA with 0.0, and let's do it in place. Yep. But yeah, before we do that, I should do this thing. Basically a null check. Okay. So check. Okay, my RAM is keep on increasing. I am guessing I will get a error. Is it because of this? Hmm. It looks good because I'm consuming all of the resources, but it's bad that it might restart. Okay. Once I will do that, then I need to divide my train and test set, right? Yeah. So I can use folding here. Yep. But yeah, because of memory constraint, I don't know I should use them. All these decisions. Okay, making train and val sets. Okay, so here I will use my, so this thing create folds function, and let's make here helper function. Write my code. Is it done? Okay, still preparing. Still preparing. Okay, it will take time. $6 million. Okay, but yeah, before that I should prepare all this. So here I will doing create folds, and yeah, once I have this, it will give me a data frame, so I can mark them with. Actually, in this set, I don't require to do five-fold training because I will get a lot of data. So five-fold training will be a little uh, overwhelming for the RAM. As you can see, it's already red. Instead, what I can do is simply do it a knife or train test split. That will be better. Okay, so entire columns are null or what? I need to check that. If these are entirely null, I don't know whether my model will fit or not. Okay, so I can choose this thing. Still taking time. Has anyone already did this? Hmm. If someone has already done this, then it will be better. Um, because I cannot, like, every time I cannot do this. I can save it, but I'm just doing for one partition and it's taking this much of amount of time. Mm, I need data preparation. Okay. Mm, Subpickle format. There's a code to reduce memory. There are no columns with this, right? And are there any strings? There are only floating variables and integer variables, so only numerical columns are there. Not sure why he has taken this. Okay. Hmm. It's taking the first partition. Clean RAM decreased by 43. Hey, how is it measuring this memory? Decreased by 33.4. Reduce memory. Start mem and mem. Okay. Last one is 2 gigs. Well. I'm fucked. Hmm. It's reducing. Yeah, look at this. This is Python's um, lazy garbage collection. It doesn't do anything. Like, if it was immediate, it would have been easier. But I guess they have their own nuances to keep it like this. But yeah, let's prepare this. So train data, val data. So whatever data frame I'm getting, so I can take the. So let's do split index. So split index, let's say whatever I'm getting, I want so train ratio, let's say let it be 0.7. So what I will be doing is train ratio times whatever data frame. So I will be using 70% of the data frame data into my training. Okay, and rest of the data as my validation data set. Okay, so this will be data df. Okay, once I do this, so I'll be using this much amount of data in my training and data df of this much val sorry, this will be split index of this. So yeah, these two will be my train data and val data. So we can check the size of them. Okay, I don't like this. Shape, shape. Yeah, so and one more thing I will be needing is this thing, the weight matrices. So so train weights and val weights basically. Okay, so train data, uh, weights, train weights. Okay, and I will be taking this val weights. So this I'll be using for my R2 score splitting data. And extracting weights for computing R2 score. Okay, this and other thing I'll be needing. Okay, I have this. Then do I need some kind of feature engineering? So I have something in my mind. So because I have been given date IDs and time IDs. Okay. So this time ID, I know it's kind of periodic. So it's not absolute periodic because in the uh, what in the data they have mentioned that the time intervals between time IDs may vary. So they are not actually periodic, but uh, since they are only IDs, I can do some kind of a transformation over them. Okay. So I can put them in a sine functions. Okay. And another thing I can do is some kind of a cosine function. Okay. Because per date ID, I will have some increasing value of this thing, the time ID. Okay. I have to scale them. Okay, instead of scaling them, I can simply put them as a sinusoidal curve. And how I will be doing that, because as per my last EDA, this EDA 2, yeah, I've scrolled down from infinity and beyond. Okay, cool. Here you can see like time to time differences are 30 seconds. So if I say, so in one day I have 24 hours, okay, and each hour has 60 minutes, okay. Now that basically means I have 120 30 seconds, right? So I can say, so this 27 I can consider like rounded up as 30, okay. Okay, so with that I can say, so the overall capturing will be 24 times 60 times 2, 2 being because, so this one, so I will have 2 times, I will be receiving 30 seconds in 1 minute, right? So I have 60 minutes, that means I will receive 120 times 30 seconds, and for a day it will be 24 times 120. Now this number will come out to be what, at 4 4, it's 14 14, so 2880. Yeah, so this many times I will be captured, so time IDs will be captured. So just an assumption, so this will be like my length of the period. Okay, this is still a hypothesis. Don't know whether this will work, but I have this intuition because as per this EDA I found out that per time differences, like time to time differences, there will be a 30 minutes gap between the next time ID. Okay, so for example, I have a time ID here at t. Okay, so the next time ID I'm receiving has a overall mean difference of 30 seconds. Okay, so this many times I'll be, the time IDs will appear, so I can use this for a period. Okay, I can do that, or otherwise I can simply convert them into radians and compute the sine values of them and cosine values of them. So these two feature engineering I can do with time IDs, sine and cosine. Okay, this is still experimental, so I guess I will be doing that the next step. I want this data to get loaded so that I can train, but okay, I have this. Okay, to do sinusoidal conversion of time IDs. Okay, now once I have this, I need feature calls. Now I have my config where I have mentioned all this, but first for the baseline I can simply use these as my features. Okay, so feature calls are this. Now train data, Okay, so train data this, and label is my responder 6. And yeah, one more thing I need is this one, responder 6 dot lag 1. Yeah, all these features I need. And this one still running. Okay. I got this. So train features, I can say train features will be feature calls, train data, and my val features will be val data, feature calls. Then mm, train labels will be train data of label, and val labels will be val data of label. I can do values, uh, values. Okay, so I got this, and I have already extracted my train weights. I can make this step here to make everything in a line, in a single code block. Okay, so I can make this command extracting features, then extracting labels. Okay, and I can here add date ID and time ID for later use, but for now I'll be using this. Okay, and once I have this, so let's uh model. Okay, okay, not sure. Okay, so let's start with Xgbost. Xgbost. I have to see the official documentation. Yeah, this one. uh is there a quick guide? Yeah. I don't want to use the Xboost of sklearn because it has some issues, like uh, this one, like this native Xboost package is better, as there are because as sklearn is written along with many different algorithms, like ridge regression, lasso regression, linear, then KNN, all those algorithms are written. So uh, like that overall package, that sklearn has to be aligned, like supporting all those algorithms, right? But Xboost has its own package, so they have faster updates, and they are also compatible with GPUs. So that's why using the native Xboost is better. Like instead of doing sklearn dot boosting and importing Xboost, okay, you can use the native Xboost. It's better, and also Kaggle provides that. Like Kaggle has the package already in their Python environment. But yeah, if I search in instead of, let's say, B classifier, I need here regression, right? Regressor. Will I get anything? Yep. Yep. Okay. Where is fit? Dot fit. Okay. Yeah, I am looking for this dot fit. Okay. I need this one. And yeah, let's copy this. Paste this. So Xcb. So they must be importing Xgbost as Xcb, right? Why this documentation is so big? Okay. I need this one. Okay. And estimators. Let's start with 200. It's written in the documentation, right? Okay. What all things I can do? I need some kind of parameter. Yeah. I got estimators. Then I want to get the yeah, max depth I need. So let's start simple. Let's say max depth is 3. Then what else I need? Okay. Random state. Yeah, I need seed value. So in my config, I have set the seed. Okay. Then yeah, I can simply modify the learning rate. Let's keep it 5e minus 3. Minus 3 will be very less. Let's keep it to 2. Okay. Okay. Once I have this, I can simply call fit, and they also do the sampling, right? There should be some kind of weight. I remember it was some sample weight they call. Yeah, sample weight. So here I will be doing this and train labels and sample. Was it sample weight or weight? Yeah, sample weight. So here I will be giving this thing. Okay. So I got this. Now once my model is done, then I need to save that model. Okay. So dot. So yeah. So usually we save this models in job lib kind of packages. Okay, but there is a better package. Okay, so I guess most of you must be familiar with pickling. Okay, but there is one internal package of Python which is much faster than your normal pickle. Okay, so this one. Okay, this is much faster than normal pickle. So you guys can check this out. I can also show you this. See pickle versus normal pickle. Okay, So loading and everything is pretty faster in this package. Okay. As you can see, like it's written in C instead of no what's the native C package? Yeah, this one. You can see that the pickle model already imports C pickle if available. It is optimized C's, so it's mostly written in Python. Okay, and it's pretty fast, and like you will face faster loading and faster writing and that. So we normally use pickle when we want direct, like when we want to directly store the object as a binary. Okay, instead of converting to some other data types. So for that we use pickle, and this underscore pickle is much more efficient than the normal pickle. So yeah, you guys can check that out. So we have to save this. Let's call it XCB model, and for the experiment, let's call. Actually, I should create a folder. If not, let's go exist. So if my X model, I should call it XZB model, and it's a pickle, and I want to write binary as model file. Yeah, then I will use cpickle dot dump. Okay, so here I will put my this thing, and I will put my model file, and I need this path, their path. Okay, so this should be, so based on my experiment I should write this. So I'm saying experiment, so partition 9 lagged data added and Xgbost. Yeah, and it will be better. Yeah, my Xgbost model will have this many parameters already, so I don't need to change it. Yeah, but yeah, I'm still thinking like it will be better if I do something like this. Params, I call it ticked, and I have all this sklearn metrics import. So instead of mean absolute error, I can actually use mean absolute error. Yeah. I have all this thing now. Can call params. So in machine learning, it's a good practice to save all your experiments, your parameters when you are training models. So all those things you need to save them. Still loading. So that's why I'm keeping this as a param so that I can write a JSON for that, uh, or I can directly put it as a pickle file. So yeah, Xgbost this. Okay, this should be my folder. And if os.path exist, if it doesn't exist, then I want this to make the path. Okay, now here I will be dumping my model. Okay, and I will also dump my config. Dev path Xgbost pickle write binary. So model params say pickle dump params model params Xgbost model params. Okay, so I'm saving all this, And yeah, before that, I need to run a quick validation. Okay, so for validation, I need R2 score, scale metrics, import. So yeah, I got this R2 score, and I have weights, right? So first y true, and y parad. Okay, so on a validation, I have to get the predictions. So reg dot y val features. This is my y pareds, y val pareds. Then this will predict. Then R2 score. And this will be R2 score, R2 score. This will contain my val labels. I must this, yeah, train weights. And this will contain my y pred, y val preds. Then, or I can put it like simply val preds. Then sample weights, right? Okay, weight. Sample weight will be my val weight. Yeah, val weights. Okay, now I can put this at this. Okay. Okay. Cool. So this will be my later on pipeline. I can add more models, but yeah, I was hoping to start with a simple linear regression kind of model, but I guess this will take some time. So for my baseline, I should start with Xgbost. Yeah. Experiment partition 9 lag data added Xgbost. So yeah, this will take some time. I will make another video on this after I get that result. But yeah, this is how I'll be proceeding further. Uh, More feature engineering I need to do on that features and responders that tags data. I am still not sure how will I use them because yeah, I I really don't understand the necessary of that data. So yeah, so I hope you guys learn something new, and I'll be uploading more videos on this. So yeah, now I need to stop this recording because it's already pretty late here. I will mostly put it as a version here so that it will run in the background, and like tomorrow I can see the results. So yeah, so just stay tuned to watch more videos on these competitions. Yeah, I'll be uploading more on this. So yeah, stay tuned guys. Thanks for watching.